Another term in process management is multitasking. This term is single-user variation of multiprogramming concept. Multiprogramming and multitasking both refer to the same concept of systems' capability to work concurrently on more than one task. But what are the differences between the two? Some OS or operating system authors prefer to use the term multiprogramming for multi-user systems, while multitasking is used for single-user systems. So multitasking eases user operation and saves lots of time when a user has to switch between two or more applications while performing a job. While multiprogramming is interleave, what is this interleave? I searched in the internet and this is the term. Interleaving is a technique used in disk storage and RAM memory to improve access performance to storage by putting data access sequentially into non-sequential sectors. So in computing, that's the meaning of interleaving. So multiprogramming is interleave execution of multiple jobs in a multi-user system, while multitasking is interleave execution in multiple jobs, take note, in a single user system. Another term in process management is what we call multi-threading. Let's define first what is this thread. Thread, it is a lightweight process. It is a process, but it will not carry much load in the CPU. So threads are popular way to improve application performance. In additional operating system, the basic unit of CPU utilization is process. So each process has its own program counter, its own register, states its own stack, its own address space. So in operating systems with threads facility, the basic unit of CPU utilization is a thread. So a process consists of an address space and one or more threads of control. So take note of this, each thread of a process has its own program counter, its own register states, and its own stack. So all the threads of a process share the same address space, and all threads of a process also share the same set of operating system resources. So threads are referred to as lightweight process, while traditional processes are referred to as heavyweight processes. And let's go back to the definition of what is a process. Process is a program in execution. The diagrams will show you the difference between single-threaded and multi-threaded processes. So take note of this. A single-threaded process corresponds to a process of a traditional operating system. So what are the motivations for using threads? First one, overhead or the expenses involved in creating a new process is considerably greater than that for creating a new thread within a process. So new thread uses the address space of its process. And the overhead or the expenses involved in CPU switching among peer threads is very small as compared to CPU switching among processes. So resources are shared more efficiently among multiple threads of a process than among multiple processes. So users find the threads model more intuitive for application programming. Another term is multiprocessing. So system with two or more CPUs having ability to execute multiple processes concurrently. And this term, multiple CPUs are shared to process either instructions from different and independent programs or different instructions from the same program simultaneously. And we have two types of multiprocessing. One is tightly coupled. What is this? Single system-wide primary memory shared by all processors, while loosely coupled, each processor has its own local memory. Another term in process management is known as time sharing. So it is defined as simultaneous interactive use of a computer by many users in such a way that each one feels that he or she is the sole user of the system. This term, many user terminals are connected to the same computer simultaneously. It uses multiprogramming with a special CPU scheduling algorithm. So there will be a short period of time during which a user process gets to use CPU, which is known as time slice or time slot, or known as quantum time. So CPU is taken away from a running process when the allotted time slice expires. Have a look with this process state diagram for time sharing system. First, a new process or job will be created. It will go to the ready state. So there will be a register that will dispatch the process if ready for execution. So job is allotted to CPU for execution. Take note, there is a quantum time of a small unit of time defined how much the process will go to the running state. If the time allotted will be expired, it will go back to the ready queue and it will wait until it will finish. If the process will be finished, so it will be completed, it will go to another state which is finished. If the running program will need an input output to be completed, but it's not available, so it will go to block state. Once I/O will become available, it will go back again to the ready queue. So the difference there in time sharing, there will be allotted time slice or known as quantum time. What are the requirements of time sharing systems? We have here number of user terminals, large memory to support multiprogramming, memory protection mechanism to prevent the job's instruction and data from other jobs, job status preservation mechanism to preserve job status information when the operating system takes away CPU from it and restores this information back. We have a special CPU scheduling algorithm that allocates CPU for a short period one by one to each user processes. An interrupt mechanism to send an interrupt signal to CPU after every time slice. What are the advantages of time sharing systems? We have first, reduces CPU idle time. It provides advantages of quick response time and offers good computing facilities to small users. So that's all about process management, and next video I'm going to discuss about memory management.